had people build self-driving cars, well not actually build it, but code self-driving cars in the past. Well, a model of for self-driving cars. We've had people build quadcopters. We've had people build apps, and we've had people do research and try and get the research published. So the idea of this class is that you choose something that you want to do, and we are going to help you achieve it. But before we go and try and figure that part out of like, helping you achieve what you want to do, let's figure out what you want to do, right? So I want some answers here. Why are you here? Why are you taking CS 125? What drove you to take CS 196? Let's see some hands.
Are there any DGS majors who want to switch to CS? Alright, there you go. Alright, do we have any Mechis? Physics?
More simply, how many of you want to switch to CS? Excellent. So why do you want to switch to CS? How many of you want to get do a career in CS? Okay, excellent. So in that case, one of the main tools of the class is to move from a beginner to CS, and making you someone that Google would want to hire. Mostly by the end of this semester. And we've actually probably get back here. So, Austin here, I'm going to explain how it is.
Alright guys, hey, my name is Austin. I think I pitched to some of you guys in the 196 discussion sections, or sorry, 125 discussion sections today. So we're just going to go over the syllabus really quick. I'm going to tell you a little bit more about what the class is actually about and how we're going to go about actually coding and doing projects. So let's start off with a brief roadmap. So the first 4 weeks is going to be intro to Python, basic programming, intro to Python. I'll be teaching the first four weeks, and that's going to assume that you don't have any knowledge of computer science or programming at all. It's going to take you all the way up to a little before the end of 125. So we probably won't go all the way to recursion, but during the first 4 weeks, we'll probably cover a lot of the material that you would have in 125. So that's going to be the first 4 weeks. Who here has had previous programming experience? All right, and of those hands that are up, who has experience with Python? All right, okay, so that's okay. So for you guys, the first, like today's lecture might be a little bit boring, but definitely starting next lecture, it'll start heating up a bit. The first 4 weeks are going to be very intense. We're going to release a homework assignment today. That's going to be due next week, and then we're going to release a homework assignment that's due weekly for the first 4 weeks. And we need to do that in order to make sure that you guys have solid programming foundations and fundamentals. So it's going to be a little intense. And after the first 4 weeks, we're going to split you guys into groups of anywhere from 4 to 8. We're going to assign you a CA. We have many wonderful CAs, 35 CAs actually. And we'll assign you a CA, and the CA will guide you in making a project that is interesting to you. In the past, we've had mobile apps, web apps. We've had some hardware hacks. So basically anything that you want to build, we'll teach you how to build. You don't have to do it in Python. You can use any technologies that you want. And during those 11 weeks, we hope that you can use the knowledge that you've gained from fundamentals of programming, whether that's from 125 or 196, in order to make something cool, hopefully. One of the reasons why we want to take this project-based approach to computer science is because not a lot of other classes kind of provide this opportunity. 125 and 225 are great classes, but they don't really focus on practical applications of computer science. So that's the main reason that we're here, to teach you guys that. And so with that being said, let's go right into grading. So basically what's going to happen is the first 4 weeks, there's going to be 4 homework assignments. You'll have to do all of them. We're going to have a separate section for how homework is going to be delivered and how you're going to have to turn it after a lecture on the introduction of Python. And so homework is obviously part of your grade. A huge chunk of your grade is going to be the project. So, your finished product, how does it look? Is it functional? Did you guys use best practices in making your product? The product is going to be split into 2 checkpoints. The first one is, I guess, the midpoint, which is basically how are you doing halfway through the project. So we'll have that from week 5 to 6. And then, obviously, at the very end, we'll evaluate your project as a whole at face value. Like I said, you will be led by a CA who knows what they're doing, so don't worry about that. They'll teach you everything you need to know. All you need to know, all you need to bring to the table is fundamental programming knowledge, which we'll teach you. And you'll be graded on participation. How do you try? Like did you commit any lines of code to the project? So if you're in a group of 5 and you didn't commit any lines, then you're probably gonna fail the class. And also your improvement from the beginning. So if you're already an experienced developer, we want to make this valuable for beginners as well as experienced programmers. So we're going to really push you to do well. A lot of projects last semester had groups that were very, very experienced, and we really pushed them to create cooler things and things that are definitely above the benchmark for maybe students that hadn't programmed before. So there's that. I know there are a lot of you who don't program, so during the first 4 weeks, we're going to have what's called hackerspaces, which is basically just office hours. Do you know the
It's probably going to be on Wednesdays at 5 o'clock and 34:05.
Yeah.
But we will be posting this on Piazza. But we guys going to be on Piazza. And if there's any change to that, we will let you know a day in advance.
Yeah. Okay. So yeah, there's that. Make sure you join the class Piazza. And a lot of you guys are gonna have trouble with this first homework. It's a big homework. I think it's 20 problems. They're pretty simple problems. If you have done Python before, this should take you maybe 5-10 minutes. But if you haven't programmed before, this is going to take you guys a long time. Don't spend more than 4 hours on the homework. Come in to the hackerspace, and the CAs there will literally walk you through the problems if you need it. I'll be there, and a few of the other CAs will be there to help you out. So don't get stressed out about it. This is kind of like a trial to fire kind of thing, and we really want you guys to have these fundamentals before we begin the projects. Other than that, you should attend as many hackerspaces as possible. We usually teach pretty interesting things in hackerspace. The first 4 weeks, it's just going to be teaching you Python basically. But after that, we'll teach things like web dev or mobile dev, tips and tricks, best practices, stuff like that. Do we have any questions so far? Yeah.
Are there not spaces on Enterprise to register here, or is there?
Yeah, there should be plenty of spaces. Yeah.
Wednesdays, 5 to 6.
Yeah.
5 through 8.
No, sorry.
5 to 8 there. Yes.
No. Yes. Where?
Oh, okay. Oh, where? Siebel 3405. If it is not in Siebel 3405, we will be posting it on Piazza.
And we'll also email it to the word. Yeah.
Python 2 or Python 3?
2.7. All right, I guess I should explain this a little bit. You will have a say in who your teammates will be, but we do have an automated algorithm to match you guys up, and that's going to be based on experience level. We don't want a beginner to be matched up with a really experienced programmer, and also based on your interests. We don't want to put a mobile developer, a web developer, and a hardware developer in the same group. Obviously, we want to take your interests. So last semester I think we were pretty successful in matching groups with people that they wanted to work with. So if you guys don't like your group for whatever reason or don't like your project, you guys can always complain to us and we'll make a change. It's not a big deal. Yeah.
Are we gonna have to download any software before actually that?
Yeah. So kind of. So we'll be using Python 2.7. Which you will need to download if you have a Windows. On Mac, Python 2.7 is default, I think, and the text editor is also default, so you shouldn't have to download anything. But yeah, again, if you have any trouble with installs or anything like that, make sure you come to Hackerspace tomorrow. We'll take care of it for you. And also, EWS also has Python already installed and already has the default text editor already installed. I'll tell you guys a little bit more about that once we actually start. Anyone questions? Yeah.
So what exactly is hackerspace? Because it seems like an office hours are supposed to go to the learning.
So yeah, the first 4 weeks we're devoting Hackerspace to basically just office hours. We're gonna help you with your homework. If you have any questions about Python fundamentals, we'll help you out there. And then after that, we're gonna have occasional Hackerspaces for things that you guys want to learn. We're gonna definitely want your feedback on, hey, what do you want to learn in this class? Some classes, are really interested in web dev. Some people might be really interested in hardware development, stuff like that. So we'll take that into account, and then we'll offer Hackerspaces for the people who want it on topics that people are interested in. We're also going to be covering some of the more fundamental of those topics, those extraneous topics in class. So you guys will be good for that. Yeah. So anyone else? No questions? All right. So Modi is going to talk a little bit about microlessons.
Right. So also mentioned a lot of topics. You mentioned hardware, you mentioned web, you mentioned a lot of these things. And someone was a little bit confused about are we going to be learning in Hackerspace? Sort of. So the way this is going to work is that in all of our future lectures after these first 4 weeks, we're going to be teaching you a thing or two each week about CS. We call these micro lessons. And as I mentioned, we're going to, during each lecture session, we're going to do either 1 or 2 micro lessons. And these micro lessons are going to be basic introductions to web, to computer vision if you want, to machine learning, to hardware. And we're actually going to leave a lot of these topics to a vote. Like, what is it that people want to learn? And if you decide that you are interested in this, then we will be having an additional workshop at the Hackerspace that you can attend and take a deeper dive into these topics and really see if you enjoy them and really figure out how to get started on these topics. We're also going to be having homework every other week after the first 4 weeks. That are going to get you really set with a lot of the fundamentals that a lot of other universities don't touch until like their third year. Things like pointers and memory and how these things work. And you're going to UC, so instead of learning it in your third year, you actually learn it in your second semester here. You'd be learning it in CS225, and a lot of those homeworks are meant to get you very comfortable with the early concepts of CS225. And in the spirit of starting up with that, let's get started with the absolute fundamentals of Python.
Alright, so I'm going to start the Python lecture now. I'm not exactly sure whether I intend to put an outline up online. You guys should probably take notes. And it's going to really help you guys pay attention for those of you who don't know the program, or else you guys are going to get drilled this weekend. So yeah, make sure you take notes. Alright. And for those of you guys who already know Python, this is going to be probably pretty boring to you, so I apologize. But we'll get better next week. Alright. So let's start. I'm assuming all of you guys took basic algebra, right? So, can you guys still hear me? Cool. So, I'm assuming that you guys all know basic algebra. So, let's start with an equation. So, let's start with q plus x equals y, right? So this is obviously, what is this? Just an equation, right? So you can say that this is, f of x, where the input is x, your variable is x, and whatever you put into x manipulates y, right? So your variable for this is f of x, and your function is, your variable is x, and your function is f. I don't think that. There's no command, it's a Windows computer. Alright, here we go. Okay, sorry.
Is that readable for the people in the back? No. No, alright. We need it a little bigger. We need it a little bigger.
Alright, okay. So this is going to be really annoying because I need to scroll down to the output, but we'll deal with it now. Also, take my word for it. This editor sometimes bugs out, and sometimes I'll put in right things and it does wrong things. We tested this before, so it's not my fault. So if something's right, just take my word for it. Okay, so we have f of x here. The function is f, and your variable is x, right? Pretty simple. So we have this variable x here, and let's say we make that. What is that? What? Alright, let's set x equal to 4. What? My keyboard is English. Alright, okay, we're good. So if we set x equal to 4, and we have the equation f of x, where 2 plus x is equal to y, what is y? What is y, guys, please? 6, thank you. Alright, so what do we do there? We set the variable x equal to 4. And when you're thinking about programming, it's kind of the same thing, where we have these functions, and in Python they're called definitions. They take whatever input that you might want, and then they give you a desired output based on actions that you want to take to manipulate that output. So let's start with some basic operators. So what is an operator? Unary operators include, plus, minus, multiplication, division, power, etc. So those are some unary operators, and what unary operators are it's a symbol or character that takes into account two variables, and it'll manipulate them in some way depending on the nature of those variables. So let's look at the plus example. So plus is pretty simple. If I do 2 plus 2, or sorry, 2 plus 3, that's just going to return 5. And we're going to actually print this. So we're going to print 2 plus 3. All right. So let's run this. So that gives you 5. I don't know if you guys can see that. There you go, 5, right? So that's pretty simple, and that should be pretty intuitive. So instead, let's define a variable. We'll just call it variable, and actually let's call it food, and let's set that equal to 3. Now, I'm going to replace the 3 in the print statement with foo, and what do you guys think is going to happen? Wow, you guys are really smart. There we go. It's over here. Yeah, it's a little thing, but there we go, right? So that should also, again, seem very intuitive to you, right? So what we did here was we have a print function, and you guys can black box the print function right now. Don't worry about how it works or how it operates. All it does is it prints whatever is in those parentheses. Pretty simple. And we have a variable called foo, and we assign foo what's called an integer, right? You guys all know about integers. You guys all have already taken basic algebra, hopefully, right? So there's your integers. And that's what, in Python and in programming in general, that's what's called a type. And a type is, defines the nature of, character or, basically where you want. So we have 3 here, right? And that's an integer. So we'll call it integer. Actually, in Python, it's so this is an integer. And we also have a type called a string. This is a string. And what a string is in English is it's basically just a word, right? So a sequence of characters. And there's also a data type called character. So C could. I don't like this one. C character, right? And there's also what are called doubles, and doubles are floating point numbers, so basically decimals as we know, right? And there are a lot of other types, right? So, but these are the types that we're going to focus on right now, and they're the ones that we're going to use in our example. Oh, sorry, there's one more important one. So this is an example of a Boolean, and Boolean is true/false. There's only 2 values for Boolean. It's true/false, and a Boolean value for true means something is true, and a Boolean value for false means something is false, right? So that's pretty simple. So we're going to use those 5 types in our examples. All right. So I mentioned arithmetic operators. Let's go through some relational operators. Relational operators are like less than, greater than, less than or equal to, greater than or equal to, double equals, and where's that? Relational equals. And I'll explain that right now. So, less than, greater than, equal to, or less than or equal to, those are pretty self-explanatory, right? Basic math, basic algebra. What aren't explanatory are these 2 at the end right here. These 2 at the end, double equals and exclamation point equals. So, let's do an experiment. We'll do print. 2 is equal to 2. So, intuitively, what do you guys think that's going to do? Anyone? Alright, what does it actually do? Anyone? I think some of you guys said that you guys already programmed your Python, so it should be pretty intuitive. Yeah, it does return true. Or it should return true. Oh yeah, sorry, the first one. Yeah, okay, I'll put this in comments. Yeah, that's another thing. This editor doesn't return any errors or anything, so it's kind of hard. Yeah. There you go, it's true. Yeah. So what this double equals does is it takes two variables or values, anything that you want, and it checks for equivalency, right? So it takes those two things and it says, are these two things equal? And if they are, it returns the Boolean value true. And if they don't, it returns the Boolean value false. Should be simple. What do we do here if we wanted to replace those twos with variables? Does anyone want to give me the code for how we would transform this into a variable operation? No one? Okay, I'll do it. We have foo, which is a variable, and we have bar, which is a variable. And we can replace this with foo, and we can replace this with bar. And we can put 2 here and 3 there, and then if you run this, it'll return false. Take my word for it, it's false. So, you guys understand what's going on here? All I did was I took those actual integers, I replaced them with variables, and then I assigned numbers to those variables. Now there's something pretty important about this that's different in Python to other languages. One is that variables aren't typed, which means literally I can, instead of assigning 2 to foo, I can literally put a string there, and it's not going to complain. So when you have a variable in Python, you can literally assign any value to it you want without the taking. That could, foo could also be a boolean, it could be a double, it could be an integer, it could be a string, it could be a character, it could be anything. Okay? So take that into account. And also, this should be also be pretty intuitive, but if I run this, what do you think is going to happen? Yeah, sure. So one thing that you really have to look out for when you're programming are these types. Because sometimes you're not exactly sure what type you're dealing with, and if you do equivalence operations like this, it could return a value that you weren't expecting. Let me show you an example. We're going to assign foo to the double, 0.1 plus 0.1 plus 0.1. And we're going to assign bar to 0.3, and then we're going to figure out whether foo is equal to bar. So what do people think is going to happen? Yeah, so it's this one actually. It's false. Why is it false? Can anyone tell me why this might be false? Anyone want to take a guess? Yeah?
The first expression is not a correct assignment.
Yeah. So basically, the moral of the story here is that when you do, when you're messing with doubles, it's not going to be exact. So foo right here adds 0.1 plus 0.1 plus 0.1, which we know should be 0.3, but because it is a double, there is inaccuracy. So when you check foo against bar, they're actually slightly unequal. Slightly unequal. And we're going to prove that right now. Let's take foo, and let's subtract bar from it and see what we get. Right? Just foo minus bar. Again, unary operator. We give one side a variable called foo, and one side a variable called bar. We subtract them. Let's see what happens. And it's this like ridiculously small number, right? That's e to the negative 17, I can't see, right? So that should be enough proof to show you that these decimals or doubles aren't strictly equivalent. So please keep that in mind. Let's mess a little bit more with types. So order of operations, right? So algebra again, basic algebra. You guys all know what order of operations is. So if I do print 2 times 2 plus 5, what do you guys think will return? Alright, so why doesn't it return 14? Yeah, okay, so Python follows order of operations automatically. You don't have to, put parentheses around this 2 times 2 in order to make it evaluate that in order. Python will automatically do it in order and automatically evaluate operations according to their hierarchy. So you don't have to worry about that. Another thing that you have to worry about is types again. So if we did print, let's say 3, right? We already proved that a number times a number is going to be a number, right? So, but what do you guys think is going to happen here? I took the string 3 and I'm going to multiply by 2. So what's going to happen? Alright, who said error? I know someone said error. Alright, so what are the different options here, right? We have error, right? It could throw a type error. And a type error is basically when your compiler, the thing that's compiling the program says, oh, these two things can't aren't compatible. It doesn't make sense to multiply a string by 2, right? Or it can do, it can give you something weird, right? So those are your two kind of options. So let's see what happens. I ran out of room on my output, right? Yeah. Oh, okay. So there it is. So it's a weird output, right? It's 3, 3. Can someone tell me why it's 3, 3? Yeah, so this unary operator here, this multiplication sign, it behaves differently based on what inputs you give it. So originally we gave it 2 doubles, or sorry, 2 ints, right? 2 integers, and it gave us back an integer because the multiplication sign knows, the compiler knows, that when you give a multiplication sign 2 integers, you're supposed to return an integer. When you give it 2 doubles, it'll return a double. When you give it a double and an integer, it'll give you a double. It'll automatically convert the integer to a double. Okay? And when you give it a string times a number, then it turns out that it concatenates the string depending on the number of times of the second operator. So literally, if I did this to 100, it would just do 3, 3, 3, 3, 3 100 times. So that's useful. What about, let's change this, 20 and then 4. What do you guys think that's going to return? 24, right? 24, but notice that there's no space between the 20 and the 4, right? And that's because if you look at the string here, neither of these, there's no space, right? So can someone tell me a way that we can put a space in there? How can we encode a space? Yep. Which quotation marks? Yeah, okay, so that's 2, right? You can either put the space here, or you can put the space here, right? Pretty simple. Or, the smarter way to do it is put just an empty string. This is an empty string with just a space in it. And that'll give you the space that you want when you print it out. Pretty easy, right? Alright, let's go into some division. So, let's print 20 divided by 3. Alright, what's that going to return? Does anyone know 20 divided by 3 off the top?
6.
No. That's not 20 divided by 3, sorry. Okay, so if you do this, you expect a decimal is the answer, right? It's supposed to be some kind of decimal, and then you run it, and then it's 6. So the guy back there was right. So, can you guys imagine why 20 divided by 3 would give you 6? Yep. Sorry? Yeah, kind of. So basically, what we have here is a division sign, and on both sides you have an int, and when you give it an int, Python will automatically run it out. It won't automatically convert into a double for you, or a decimal for you. It'll say, hey, I have 2 ints, so I'm going to divide them, and then get rid of the remainder and give it back to you, because an int and an int will give you back an int, which means that you can't fit a decimal. You can't fit, like, I don't know, it's 6 point whatever, let's just say it's 6.2, into, an integer. So it can't do that, so it'll just give it, yep. Sorry? Why should it be rounded up to 7? It does round. It rounds down though. Always rounds down. It always rounds down. So it doesn't matter if it's 6.9, it will go to 7. It does it. Or sorry, yeah, 6, sorry. So, yeah, sorry. Oh, wait, 6.9 will go to 6, sorry. So it doesn't matter what that other decimal is, it literally just cuts it off right after this, right? So 20 divided by 3 happens to be 6 in this case. Alright, so what if I do something like this, right? What I told you before, right? A double and an int. When you give it a double and an int, it'll automatically convert the int into a double, and you will have your correct answer. So let's see here. Yeah, there we go. 6.65, right? So that's what it actually ended up. So make sure that you keep that into account. We're going to go into modulus. So those of you guys who haven't programmed aren't going to know what this is. I'll explain it to you. Modulus. So, does anyone here actually know what modulus does? Yeah? Right. So, let's do it again. So, let's print 10 modulus 3. Alright, what is that going to give you? 1. Very smart. Yes, it is going to be 1. I hope you guys believe me. It's going to be 1. Okay? So, what's that going to be? 0? Yeah, it's going to be 0. So you can imagine that the modulus is pretty useful for a number of problems, right? So if you want to find out the remainder of a number, you know, then obviously that's what it does. But also if you want to find out if a number is divisible by another number, if you want to find out whether 10 is divisible by x, and you don't know what x is, then this is a very easy way to do it, right? So x will be 5, in which case it would be divisible. So I'm going to go into definitions now. So you guys kind of learned about operators. Yep.
X and then you declare X after the print command, would that still print?
What did I do?
So say like you still right, and then after that command you say X.
That should be declared before. It's linear. So if you want to print x, then you have to declare x before it's printed. Yep.
Time modulus 2 equals 0.
Yes. Time modulus 2 is equal to 0 because what is 10 divided by 2's remainder? 0, right? Yep.
Bob, if you use the modulus, you would double.
Oh, okay, that's right. What double would you like to use? Alright, 3.3. Let's Alright, what do you think is gonna happen? This is way beyond what I was gonna teach today, but yeah, what do you think is gonna happen? I guess. Alright, what's wrong? That's your answer. And also keep in mind what happens when you modulus a negative number, right? But you guys don't have to worry about that now. We might teach it later, I don't know. But yeah, right now just worry about modulus on positive ints, right? That should be fine. Well, okay, so that's modulus. And right now I'm going to teach you about definitions. So I taught you about all the unary operators and about some types. Those aren't all the types, but those will be good enough to get you started. So if you wanted to actually write a program to do something for you, how would you go about it? Well, I'll see right now. So that's the syntax for a definition. So what is a definition? A definition is a function. Like we talked about in algebra, it's something that takes an input and it gives you an output based on the manipulations that you want to do, right? So let's say that we take in the variable x. It'll do something to x and pop it out. So let me run through this real quick. We have the keyword here, def, and keyword means that it's reserved by Python. You can't use it for other things. You can't use it for variable, right? So you can't use def anywhere else, and that's because Python, when it sees def, it says, oh, this is a function. This is a definition. So you don't want to mess with that. The next thing here is the name of your function. And this can be arbitrary. This can be anything you want. So this could be bar if you wanted to. It could be, it can basically be anything. It can be foo if you wanted to, right? So you can declare your function name any way you want, except for reserved words. So you can't do def, right? But also, there are some style guidelines that we would like you to follow and are followed traditionally in industry. So one style that people do is camel case, and camel case is like this, right? So camel case means that if you have multiple words in your function definition, you should lowercase the first one, and then at the start of every word, just concatenate it, and then uppercase it. So, for example here, the word is camel case. We take the first word camel, we lowercase it, and we append it to case, and case is capitalized, and then it keeps on going, right? You can literally just keep on, like it doesn't matter, right? Another one is underscores. So foo, bar, das, right? So those are kind of the two standards that at least I learned. I'm sure there are others, but yeah, when you guys are writing function definitions, try to stick to one of these. We're not going to grade style yet. So style is basically, you know, you can write a piece of code to do what you want, but in the end, somebody else has to read that code. In the end, you have to debug it at some point in the future, right? So it's really important that you make your code readable, easy to understand. There are so many ways to write a program or a function in an unreadable way, and that's really dangerous for when you have bugs, because it's gonna lengthen the time you have to spend on debugging. And also it's gonna be really bad, especially bad if someone else tries to read your code, right? Because if you write it, at least you know kind of some list of what you're doing. If someone else tries to read your code, they're not gonna have an idea. So style is really important, and we're gonna start enforcing style, and we'll be actually taking off points for bad style starting next week or the week after. We haven't decided. But we're definitely going to take off points for style if you guys use bad style. And don't worry, we will give you guys a style guide with a certain list of guidelines that you guys have to follow. But just keep in mind that this is important and writing that your code cleanly. Alright, so let's go back here. And then, okay, what's next? So we have these parentheses. And within these parentheses, go your variables. You can put in as many variables as you want, and it'll take them all in. So it could be X, Y, foo, right? So take in as many variables as you need in order to, do it. So let's write a basic function here. The sig, foo, and bar. Oh, and sorry, I forgot. So the variable should be separated by commas, and also at the end of this parenthesis, you want to put what is it called again? Colon? Yeah, colon, right? So you want to put a colon there, okay? And after that colon is where the function starts. Another thing that's really important is that Python is space sensitive, which means that, so this space right here is important. If it's not right, Python will not run. And a lot of people who dislike Python dislike it because of this. They think that the space is annoying. Who here knows Java? So in Java, you use brackets, right? So bracket, and then you can put anything you want in there, and you don't have to worry about space. Although you should, but you don't have to. It doesn't matter. In Python, it does matter. If you don't put the correct number, of spaces or tags before the line of code that you want to write, it'll either do something weird or it won't run. So traditionally, it's supposed to be 4 spaces. I think Google uses 2 spaces. I use 4 spaces or a tab. So just keep that in mind. If you're getting syntax errors when you start coding, it might be because of your spaces. And spaces are really annoying because, especially if you copy and paste over code, which you guys shouldn't do, but if you copy and paste over code, then sometimes it does weird things with the spaces, and even though the code will be completely correct, it won't compile. So you guys just need to make sure that your spaces are correct. And the way that you fix that is either to use an IDE, which is an integrated development environment, and I don't expect any of you guys to use a Python IDE, but if you do, there's a really good one called PyCharm which you guys should use, but you guys probably aren't going to be using IDEs. So all you need to do is you need to backspace up and then enter again, and then the space issue should be fixed. About editing, so this is an online editor here. It's called Sculpt. But you guys will probably be using what's called idle. Let's see if it's installed here actually. Nope, it's not. Okay, so idle is the default text editor for Python. It literally just looks like a notepad document, so it'll look like this. Except it's going to be called idle. And this is where you code. So you would be like def foo, foo, bar, whatever. And it'll give you what you want. So just keep that in mind if you're getting syntax errors. So space is important. Alright? And everything beneath this definition is going to be the body of your function. It's going to be what you want to do, the logic behind how you're going to manipulate these variables. So let's get started with a simple one, right? So let's just do foo. Alright, so let's just start with something simple. Let's add with the function plus. And again, you guys should be naming these definitions so that they're obvious and readable, right? So let's do plus, and what do you guys think this is going to do? It's going to add these two, so foo plus bar, right? And the way you call this, actually I need to return here. Return foo plus bar. That's pretty simple, right? So I want to point something out. So there's these two statements here, return foo plus bar and print foo plus bar. Does anyone know the difference between return and print? Yep. Well, kind of. It's partially correct. What? Okay, yeah, that's part of it. What else? Alright, I mean, that's, I guess that's good enough. Okay, so the difference between return and print is that print will take whatever you want and it will print it for you on the console. And the console is just this, right? Sorry. So it's gonna print here, but it doesn't actually do anything else. It just prints for you. Return actually takes that value and yields it. It gives it to you. So if you need to use that value for, say, another function, maybe you have a chain of functions, maybe you have 3, and you need the output of this function in order to use in another function, which one would you use? Return, obviously, yeah. And if you want to debug, you should use print. And I strongly suggest using print when you debug. It's really helpful. And I don't know why, but like it seems like nobody knows how to do print debugging nowadays. It's just like a lot of people debug by kind of just like showing their friends, hey, I can't debug this for me, right? And that's bad. I hate it when people do that to me, because then I'm like, here, just put print statements here. And then like 5 seconds I'm like, oh, that's so stupid, I know why not, right? So that's the first like good programming principle that I want to instill upon you, is you guys should do your own testing. You guys shouldn't get your friends to try to debug the programs for you, and you guys should use print statements in order to debug, right? You can't always use print statements. There are some situations where using print statements is really hard, but for what we're doing in this class, and probably for you guys next year, print debugging is going to be really useful. So make sure you guys get used to print.